Alrighty. Namaste. Very good morning, good evening, good afternoon to all of our viewers on YouTube, Facebook, Twitter, and Instagram. This time, a very warm welcome. And I'd like to welcome you to the 13th edition of our Flutter remote meetup. As always, I am your host, Digvijay Wanchoo. And to all of those who know me already, you might have noticed that I got rid of my old earphones with that little antenna on top, and now I'm using something else. And I hope I look better on camera. Anyway, so thank you so much for taking out the time on this Saturday and joining us here for this event. As always, we already know that COVID is not uh, letting up, and times are tough. But of course, I think this might be a little getaway for all of us to come together, talk to each other, get to know more people, and of course, get to know what's new in this technology that we love. And so, based on that, thank you very much for joining in today. And you're going to have a blast. We have tons of speakers, beautiful topics that they're going to talk to you about, and it's time to get on with the show. But first, I'd like to invite my partner in crime today on screen, Viral Sangani. He's going to be delivering the keynote and telling you all about what this event is and what you can expect out of it. So, Viral, why don't you come join us? There he is. Viral, we are not able to hear you. Perhaps you're on mute. Could you
Yeah.
check that once?
Hi.
Uh, yep, there you are.
How are you?
I'm good. I'm good. How are you today, Viral?
I'm so excited.
That is great. Thank you so much for taking out the time and joining us here today. I'm just going to leave you be with all of our audience and let you tell them what they're doing here and what they can expect out of this meetup.
Sure. Okay. Hi, everyone. Namaste. And I hope you are doing well. Let me just start by thanking you all for taking your time and joining in. Welcome to Flutter Remote Meetup. Uh, we all know that 2021 has been a pretty rough year for us, right? There had been some bad news. Second wave of COVID hit India, but we had our part of good news also, right? In technology world, we had Flutter Engage in March, and with Flutter Engage, we all know we got Flutter 2.0, and with Flutter 2.0, we have multi-platform support. So now all the platforms you can think of supports Flutter. That's awesome. At Flutter Meetup, we always aims to bring the community together and grow as a community, because that's the best way to grow together. We always try to achieve to bring the best of the speakers we can, to bring the best topics with the trending technologies and packages in the Flutter. And we always hope that when you leave the Flutter Meetup, you take with some knowledge and new information. Yeah, that's about Flutter Remote Meetup. Let me talk a bit about GeekyAnts, who we are and what we do here. Basically, GeekyAnts was established in 2005, 6. We've been working on web apps, mobile apps, and we just love open source contributions, right? We work on all the frameworks. We work on Flutter, React, React Native, Svelte, Angular. You just name it, and we work on it, right? Let's talk about Flutter at GeekyAnts. We have our heart in community building, right? We've been working on Flutter since the beta stage. Since there was no even Flutter 1.0, we've been working on Flutter, and we just loved Flutter. And we thought like there's a huge scope of Flutter, and we wanted to become a part of this community. So we wanted to give something back to community. So we started our own group of Flutter Meetup, and uh, with the only hope of bringing Flutter enthusiasts together, and talk about Flutter, geek around Flutter. And recently, we came to know that Bangalore Meetup is officially recognized by Flutter. So that's a really good thing. Then we have officially contributed in Flutter documentation. So there is a part of Flutter documentation that has been created and maintained by GeekyAnts. We've been working on open source projects like Flutter Starter. Flutter Starter is an awesome kit. I don't want to talk more about it because I'll be giving away the speech. We have a really good session on Flutter Starter in this meetup, so stay tuned. Then we have Flutter Flick Video Player in a really good package. You can find it on PubDev. You can use this package to create awesome video players and video apps. We have Flutter Marketplace. So Flutter Marketplace is an awesome place. You can go there. You can check out new Flutter themes, UIs. You can purchase it, and you can just use it into your production app to boost up your productivity. We've been also doing some experiments, writing some articles. I have a series of articles on how you can implement AWS Amplify on Flutter. And we have also great articles like how you can integrate a blockchain onto Flutter. So you can check it out on Hashnode, or you can go to techblock.geekyants.com. We've been doing experiments on multi-platform. So as we all know that Flutter has multi-platform support, so why not experiment with it? So since March, we had some requirements working on Flutter Web, Flutter Desktop. I myself have worked on Flutter Desktop and the results are amazing. So that's really huge. Let's talk about today's agenda in our meetup. For the first, we have Madhav Bansal talking about why do we need Flutter Starter. We will teach you and tell you why you need Flutter Starter Kit, how you can utilize the most about it, and how you can boost up your productivity. Then we have Ganesh talking about FCM messages with Flutter, how you can integrate Firebase Cloud Messages with your app to increase your retention rate of users and to re-engage the users with your app. So that's a great thing. Then we have Principles of 3D Design in Flutter by Pratap Thakur. So this is a spoiler alert. He will be showing you an awesome 3D animation he has done in making a Royal Enfield bike 3D. It's awesome. You should check it out. Then we have running Dart on ARM servers by Swan. Again, and really awesome. We all know that Dart compiles it natively into the architecture you're running on. But Chris will show you how you can run it on ARM servers, how you can achieve cross compilation. That's a really good speech. You should check it out. Before ending, let's just talk about code of conduct. Be friendly and network, topmost priority and the most important point. Then don't use any hate speeches or inappropriate comments, because why should we? Don't use any racist comment in the comment section also. Keep it simple, right? We are here to learn, so keep learning. Ask your question in the chat section only. You might have questions after each session, right? So just put your question in the chat section and we will get back to you. Don't spam your question in the chat. There is no need to paste your questions again and again. Eventually, we will get back to it. Yeah, thank you. Enjoy the event. Digvijay, over to you.
Hi again. That was awesome. Viral, thank you so much for all of that information and guiding all of our viewers into how to enjoy and make the best of this event today. I think it's also important, since Viral mentioned that we are here only with the sense of building a community around Flutter and getting all of our community members together and talk about these things and that we love about it. I think it falls on all of us to make sure that the people who aren't able to join us today know what we are doing here. So do remember to tweet about the event on Twitter using the hashtag Flutter BLR, and let the world know what we are doing here today and what all new things that we are there that we are learning today. Also remember to post about it on your various social media channels. If you're on Facebook, if you're on Instagram, if you're on Twitter, if you're on Reddit, go ahead, tell the world about us and what we are doing here today. On that note, Viral, thank you very much for letting everybody know what the agenda of this meetup here today is, and perhaps I'll see you towards the end of the event.
Yeah, sure.
Perfect. See you then.
Yeah, bye.
Bye. All right, guys. So that was Viral Sangani, and he was delivering the basic rules of conduct and what you can telling you what you can expect out of this meetup. I think it's time we begin with our first talk of the day. We have Madhav Bansal, and he will be talking about why you need Flutter Starter, another one of our open source contributions that Viral just mentioned. I'm pretty excited to know what Flutter Starter is all about. So let's bring Madhav on stage with us.
Yeah.
There he is.
Hey, hi Digvijay.
Hi Madhav, how are you doing today?
Yeah, I'm great. How are you?
I'm good. I'm good. Wonderful. So, as a small introduction, Madhav is freshly out of his college. He's been working with us for nearly 10 months now, but he has already made a name for himself with all of these crazy experiments that he does in Flutter. And he has also been one of the people who have been working on Flutter Starter and one of the brains behind it. So, I think I would probably let Madhav let you all of you know what Flutter Starter is all about and how you can use it to enhance your productivity. So, Madhav, over to you.
Yes, sure. Okay. So, hello everyone. So, I'm here to talk about why do we need Flutter Starter. So, let's begin. So, before starting, let me introduce myself. I'm Madhav Bansal. I'm software developer at GeekyAnts. So, here is my Twitter handle. So, moving on. This is the official Flutter Starter website. In there, you'll be able to get the docs here under the docs tab. Then we have the Flutter Starter template under the GitHub tab. So, meet Sumant Raj. He's the one who came up with the idea to start Flutter Starter. So let's get started. So before starting, why do we need Flutter Starter? Let's see what is Flutter Starter. So Flutter Starter is a kit where you can find all the code needed to build a production level app. By production level app, I mean it includes API configuration, it includes the state management, then it has the style guide, then it has the utility tools and much more. So before diving into it, let's see what was the motivation behind creating Flutter Starter. So I am assuming that all of you might have started with a new Flutter project at one point of your uh, coding career. So whenever we start with a Flutter project, Flutter provides us with a simple counter app on installation, which works fine if you're just starting out. But if you are making a production ready app, you have to do a basic setup. You have to do everything which I told you in the previous slide. So to solve this problem, we came up with this idea to have the boilerplate code inside the Flutter starter. So let's dive into it now. I'll be explaining you through the folder structure. So we have the API SDK here. Inside the API SDK, by the name it's clear it makes the API call. It has all the things we need to make an API call. So here we have the Firebase method, then we have the GraphQL method, then we have the REST methods here. So and we have the API constants.dart. Here in the API constants.dart, you'll have all the API constants you'll need to manage your API, your API constants. So inside the Firebase method, we have the API handles and auth services. So API handles the API calls which are needed for your app. Anything related to your app, the Firestore calls and everything will be kept in the API handles. Then we have the auth services. By the name it's clear, in the auth services, you'll have the Firebase authentication methods. Then moving on, we have the GraphQL method here, inside which we have the GraphQL operations, which contains the mutations and queries you will be needing to make an GraphQL call. So we have a GraphQL handler here, which will help you make the GraphQL operations, which will help you handle all the GraphQL operations for you. Then moving on, we have the REST API methods. In the REST API, we have the API helpers. Inside the API helpers, we have the API base helper class. So API base helper class, what does it do? It has all the basic CRUD you'll need to make call. Like you have to, it contains all the basic CRUD which will be needed to make a REST API call. Then moving on, we have the API exception here. In the API exception class, it will handle all the exceptions while making an API for you. So REST API helper data class will help you make the API calls using the API helper classes. Moving on, we have the API constants, as I told you before. Then the main class. Main class is common for all folders. In the main class, we'll export all the files so that you don't have to import it again and again. Moving on, we have the shared folder. Inside the shared folder, we have the different modules. By modules, I mean these are the functionality or the features you provide inside your app. For example, I have an example here. This is the authentication module. In this authentication module, you'll see we have the block. I won't dive into the block, but you know, block is the business logic which controls the logic behind the authentication. So it is same as we use the block. It has events, it has states, and we have the block to control the events as per the states. So we have the block controller here, which will provide you the singleton, which will be used inside your app. Then we have the models here. Inside the models, for this example, I use the user data model. What does the model do basically? Model provides you with the data. So how does the data gets inside? It serializes the data as soon as you make an API call. So the response gets stored inside the model. So that's the need of the model here. We have resources here. Inside the resources, we have authentication repository.dart. For this example, we have authentication repository.dart. I'll be talking about this in detail later in my slides. But for now, this will provide you with the functions which you will be using inside your logic while making an API call. Moving on, we have the app. Inside the app, you'll have all the things that you need to show the user. For example, this will have your screens, this will have your configuration, this will have the routes, this will have the utility part. So moving on with the configurations, in the config folder, we'll have color constants, which will help you set the color constants for your apps so that it may not vary from screen to screen. Then we have the global constants here. We have the global constants here so that you don't have to define the constants again and again. You can just import this file and use the constant. Same is the case with image constants. We have the image constants here. So while importing the asset image, you don't have to give the path again and again. You can just import the file and use the names inside the image constants. Then we have the theme data here. Inside the theme data, we have two types of themes basically set up for you. It is light theme and dark theme. So you can configure it according to your app. This is fully customizable. All these things are fully customizable. So inside the routes folder, we have the index.dart. Inside the index.dart, you'll have all the routes which are needed for your navigation inside the app. So you can edit this. This is fully customizable again. Then we have screens here. Inside the screens, you'll have all the screens that are needed inside your app. We have the home screen here. For now, you may have multiple screens like profile screen, home screen, the data screen, and much more accordingly, whatever your app is about. Then we have the utils here. This is something which every developer might need or every developer should use. For example, what is the main concern while developing an app? The main concern while developing a mobile app is that you care about how to resize your app according to your mobile screen. So this size utils.dart does the magic for you. It helps you make your app responsive for different mobile screens. It provides you with three different functions: .to height, .to width, and .to font. So wherever you are mentioning the height, wherever you are mentioning the width, wherever you are mentioning the font, you just need to import this file and use these three basic functions. This will do the work for you. This will do the magic for you. I'll show you this practically also. So again, we have the widgets here. Here, all the common widgets would be kept inside the common widgets, like the widgets which are used commonly inside your app, like the button, customized button. We have the customized app bar or something. We can have all those common widgets here. You need not create them again and again. Moving on, we have splash.dart. This is a splash screen for your app. It is it comes out of the box with the Flutter Starter logo, but it is fully customizable. You can have it for your need inside your app. Moving on, I'll be discussing about the REST API SDK. As we all know, REST needs a generic functions for CRUD operations. So these functions are already placed in API base helper.dart file. You don't have to create the CRUD operations for your REST API. You don't have to write the HTTP calls. These are all done for you. Then we have the REST API handler class. Inside the REST API handler class, we have the we first need to create an instance of API base helper here. As soon as we create the instance of API base helper here, you are good to go. Now we have the two examples of get data and post data here. What do we need to get the data? We need a path to get the data, right? So we have here await API base helper dot get. So we are calling the get function of this API base helper class using this instance here. Similarly, we are using API base helper dot post method here to get the post request, to get the required response here. So these are the high level functions. So how we are going to use these functions? For example, I'm going to get the user data. So for getting the user data, I need a user ID, right? So we are passing the user ID as an argument and embed user ID in the path of the API call. So the path is coming from the API constants, then the users, then the ID. So it will help you get the final response here, and then you can use your response accordingly. So you can just use it by calling the API SDK.getUserData of ID inside your business logic or the repository files, shared repository files. Moving on, we have the GraphQL API SDK. Inside the GraphQL API SDK, you need to set up your GraphQL client by setting the values of under this HTTP link and auth link inside the API constants.dart file. So once you are all set up, you're good to go again. Here is an example of how you can fetch the GitHub repositories. So here I have created the instance of GraphQL client here. After creating the instance, just need to call the GraphQL repositories method, which I have defined somewhere in the repository, and then passing the number of repositories as an argument, and we are getting response. Fine. So this is also, again, we can just call it by using API SDK.fetch GitHub repository GraphQL and passing the number of repositories as argument. We have an example app to show you further. So this is the shared resource example. So I showed you the shared resource of authentication before. So this is the authentication repository here. Inside the authentication repository, we are using the basic functions that are required for authenticating a user. We have sign up with email and password. We have login with email and password. We have get user data. So here we are just passing the arguments and then calling the API SDK methods. This is all we need to do to make an API call. So that's why we need the Flutter API SDK here. Moving on, let's see how we can get started with this Flutter starter. So this is the Flutter website which I showed you before. So here is the GitHub link. As soon as you click on the GitHub link, you'll see this page, and you can use this template directly from here. Use this template, give it a name, then you can just clone it inside your app. So I'll show you how it looks inside the app. So these are the folder structures I just explained you. So we have the API SDK, we have the app, we have the shared, and moreover, we have the run script.sh file here. This is a shell script which will help you run the app. As soon as you write sh run script.sh, this will help you run this script, and the app will be booted. Beforehand, you will need to have your emulator or the mobile phone attached. So to show the size configs, I have demonstrated two different screen sizes here. So let's sign up with this app, and let's sign up with this app too. So just a second. Yeah. So we have booted inside our Flutter starter screen. The authentication was being performed by the authentication repository, which I just showed you. We have dark theme and light theme all set up here. So these are the things which you'll get outside the box whenever you install Flutter starter. So moving on, we have some of the example apps. We have Hacker News app here. Inside you will see this Flutter starter, and believe me, it didn't take more than a day to build this app. We have the login screen as I showed you in the example. Then as soon as you log in, you can have your app good to go. So moving on, we have the weather app. Same, it works on the same login screen which comes out of the box. You just need to type the city name and click on the search button. It will go and make the API call and fetch you the data for the same. Moving on, we have the GitHub repository here app which works on the GraphQL client. So this also uses the API SDK for GraphQL to make the API call and fetch you the GitHub repositories, as I said. So thank you guys. That was all. So this is all about Flutter starter, and it's open source. So I'll want you guys to go and try it out and try new things. If they are good, if you think this should be merged, you can always create a PR and we'll look into it. Thank you guys.
All right. Thank you so much, Madhav, for that insightful view into Flutter Starter and what it can do and what it can achieve. I'm sure it's an extremely powerful tool that you can have in your arsenal when it comes to energizing your app building in Flutter. And I think what would really help our viewers would be if you could just share the link to Flutter Starter and its GitHub repo so that people can check it out and we can help our viewers get to it more quickly. That would be amazing.
Yeah.
So from the comments section, I see there's one question that's come from a user named Go Home or Go Native. And they ask, why are we creating a dependency here in API-based helper? Wouldn't that make the code less maintainable?
We are making the API-based helper class here so that it will help you make the API REST calls. Like we have all the CRUD set up for you. You don't have to again and again write the HTTP calls for the same. You can just write the overview functions and call the basic CRUD inside the API by creating the API-based helper class instance. You don't have to create again and again functions.
All right. Well, I hope that answers your question, GHGN. All right. That's all the questions that we have for you at the moment, Madhav. But I'm sure that your viewers might have more questions. And if they do have any, we can tackle those towards the end of the event. And so for that, I hope to see you towards the end of the event as well.
Yeah, sure. They can always join the Discord channel. We have the link in the documentation as well. So they can ping me on my Twitter handle as well.
Brilliant. Well, you heard it straight from the horse's mouth, folks. Anyway, thank you so much, Madhav. Thank you.
Yeah.
We'll see you towards the end.
Okay, welcome.
All right, guys. So that was Madhav Bansal, and he told you all about Flutter Starter and how you can use it to supercharge your Flutter app development and get things done very quickly. Uh, Before we move on, just a quick reminder, do remember to tweet about this event, do remember to post and invite all your friends because we are having a blast here, aren't we? Moving on, we have a returning speaker here with us, Ganesh. He is going to be talking about using FCM messages with Flutter. Why don't we have Ganesh here with us?
Hi, all.
Hi, very good afternoon, Ganesh.
Good afternoon. How are you?
I'm good. How are you doing today?
I'm good.
Nice to see you again.
Yeah, nice to be back, Flutter and
Yeah,
especially
just
GeekyAnts. Yeah,
yeah, it's like Ganesh is almost a regular with us now, and he's a very integral part of our family as well. Uh, so it's really nice to have him here and talk about all these amazing things that he does in Flutter. So as a short introduction, of course, Ganesh is a lead developer at Philips. He loves to write. He loves to photograph things and moments and keep them with him. Because he has never shared any of his photographs with me. I wonder why. Uh, Anyway, and
it
along
really takes time to edit photos, so it's a lot.
the only photos I have are yours, which we've used for this event, and I have nothing else. So I have no idea what kind of photography you do, but I would love to know, and I think our viewers would love to know as well.
Yeah,
Uh,
sure.
Alongside
Next,
that,
my Insta profile probably.
yeah, well, I'm going to look for you right after this event. That's for sure. Alongside that, Ganesh has also been featured in one of the most notable developers in Flutter worldwide. So that is one thing that he's got in his bag. I think I'll just let Ganesh tell you more about it. And of course, Ganesh, woo the crowd. Take it away.
Yeah, sure. Right. Yeah. My screen visible? Yeah. Yeah. So I'm Ganesh, and I am a software technologist with Philips. So I've been with Flutter for not long, yeah, maybe more than 2 years. I've been a part of the community, and I love giving back to the community. So since I also receive a lot, like a lot of people who keep on giving you advice, that you can, being a part of Flutter community is a huge thing, and you can learn a lot, right? So this talk is basically about FCM, and let me make it clear who this talk is for. So first of all, it's basically for beginners or novice to Firebase. So I'll be going through step by step for almost everything of setting up Firebase, right? And for FCM, right? And these are for developers who struggle with setting up Firebase notifications. So I used to be one of such developers, and there are tons of guidelines, tons of documentation also on Firebase notification. But the problem is, it is an evolving place, and the documentation or the tutorials which were created last year are invalid right now. So that is why this talk is important, right? So you can skim through the initial part where where I tell you how to find the package name, which would be very familiar with the developers who usually develop, right, with app developers. So that's fine. So let me talk about what is Fire Cloud messaging, right? So Firebase Cloud Messaging is a cross-platform messaging solution that reliably, lets you reliably send message at no cost. So this is what Firebase tells what Firebase Cloud Messaging is. And the main part which attracts me is this cross-platform messaging and at no cost. Obviously, if it is for free, why not use it, right? So definitely it has certain limitations. There's a link to that. It will be posted in the comments as well. So as there are many different limitations, but for a normal use you can use it very freely. For example, you cannot send a message which is more than 4000 kb. There is a limit that you cannot send more than 5000 registered users and things like that, but then there are workarounds for that. Okay, so let me talk about what can we do with Firebase Cloud Messaging. So basically you can send notification messages or data messages. So there are two different kinds of messages, and basically what it does is that it engages the user. So why do we again and again open a WhatsApp app or any other app like Instagram, WhatsApp, all the social media apps? Because we get a notification. If the notifications are not there, we would kind of forget those apps. Maybe not, but still the amount of times you are going to open an app will reduce if the notifications are not there. So if you can notify an app, user about, okay, something has come. So there is a thin line between notifying and also irritating. So you have to be very careful while you're using notifications, right? So you can use versatile message targeting, and that is what happens. Like you can target people based on topics or based on analytics. There are different kinds of way you can target each user. Then you can use it as a chat app. So when you're using chat app, you can send message back to Firebase or back to the FCM, and from like that you can create a chat bot also, not a chat application using FCMs, right? So how does it work? Basically, it requires a trusted environment. So that is a cloud function or a server. I will not be talking about a cloud function or server because that is a huge topic, and you will have to create your own cloud functions and server which triggers or sends messages. Then you require an iOS, Android, or a web client app. So as of now, in this tutorial, we'll be talking about how to setting up a Android app. iOS is almost similar. You need some certificates, but it's almost similar, and you can do that. And yep, if you want to learn more about the FCM architecture and how it works, there is a link for that as well. So it talks about how the FCM architecture works and how the messages are sent and things like that. Now let me talk about the types of messages which I was talking about earlier, right? So there is notification messages or display messages and data messages. Now notification messages are handled directly by the FCM development kit. So in short, what I can say is that when a notification message is sent, it will handle how it should be displayed. Everything is handled by this SDK itself, and in your client, it automatically displays the message. You do not have to say what has to be done. Uh, it has a predefined set of keys like title, body, and things like that. And it can have an optional data message as well in this. So a data message is a set of user-defined keys. So you can define your own keys telling that, okay, this is the key, this is the value should come. And the client must handle it because there is no, since it's a user-defined keys, the client is also user-defined. So it has to be handled by the client itself, right? Then there are types of targeting. So I told about versatile targeting. So there is device token. So that means you can send a message to a single device. Where can it be used is that, for example, a user is opting for some kind of notification. So recently we have built an open source app, which helps in users getting resources for the COVID, and it was built along with in Flutter India, right? Volunteers from there, and that's how this topic also came into picture. So there we needed to send a message to a single device whenever a user registers that, okay, we need to be notified when this resource is available. So that is how this device token will be helpful. Topic, definitely, for example, in the same example, if I say that, okay, oxygen has been delivered and whoever has subscribed for oxygen, let me send a topic that, okay, whoever has subscribed to that, so the device or users or the client has to subscribe to each topic, and whoever has subscribed, they will get notified. Then a set of users. So this is based on analytics data like age, how many times they have opened. There are a lot of analytics data, and based on that, you can send user messages. Let's talk about how to set this up, right? So first of all, you have to go to console.firebase.com, right? And then you have to click on add project. Once you add a project, you give the name of the project. So then the next step would be analytics. Let it be on for now because analytics give you a lot of other things, features, right? You can use it in the future. You have to choose an analytics account. For now, let us choose a default account. Then you have to wait a few minutes for this to finish. And once you are finished, you will be able to see a screen like this, right? And then what you should do is you have to click on add an Android app. So first of all, we are going to add an Android app. If you want, you can click on the iOS app where will be creating an iOS and a web. So all of them have to be separately handled. For now, I'll be showing the Android app setting up. So once you click on Android app, so there are a few things you have to fill, like the package name, the app name, and the SHA one. So we'll go in detail of each and every one. So first of all, the package name. So you can find the package name from the Android manifest.xml file or the app/build.gradle file. So let's say that you have already created an application and it's already running. You want to change the package name. So there's a link for that as well. You can go through that. There's a Stack Overflow link. It tells you each and every step in each. For example, if it's Android or iOS, how to change the package name, right? And yeah, so the easier way to create a, I mean, easier way is to create a Flutter with a package name. So whenever you create a Flutter project, it's always better to say that Flutter create and then give your organization or the package name. It's always better to create like that, so you know what the package name is, and you do not have to go and change all the files separately afterwards. So here, as you can see in the build.gradle, you have an application ID which gives you the package name. Right? This com.example.myapp and SHA1. So SHA1 is basically used for, this key is used for debugging purposes, and you can, there's a link for that as well, how to get it. If you want the shortcut, I can give you the shortcut, which is using Android Studio. So you just have in your Android Studio, when the app, the Flutter application is running, you right click on the Android and then go to Flutter and then say open Android module in Android Studio. And when you go to Android Studio, you have to open the Gradle pane, right? And you have to click on this and you say that expand all. So everything would be expanded, right? And then you click on this one, which says that execute the Gradle task. So, and then you have to type Gradle space signing report. So this is how you create an SHA key using Android. This is only for Android 4.2 and above. So if you have the latest Android, then you do not have to worry and you can directly use this. And once you sign the report, you would actually get all the different SHA keys, debug, release, and everything. And what you will have to take is the debug release SHA key, right? So this is the SHA key which you will be pasting into this debug signing certificate, right? And once that is done, you will register your application. Then you have to download the Google Services JSON file. So this is a JSON file which has all the details about what is a Firebase, which Firebase you're connecting to, all those things, and you have to copy it to the app folder Android/app. So I'll show you that as well. So this is my application. So Android app location, and here I have to paste it, right? And I'll be pasting this downloaded file. That's it. So once you have done that, next steps are also you have to just follow whatever Firebase is telling you. So here, if you see, you have to add the Firebase SDK. So what you have to do is there are two build.gradle files. One is the project level and the other one is the app level. So first I'll take the project level one and I will add the Google. So as you can see, it's already there, the Google. I only had to add this line wherein the Google services is added 4.3.8. Okay, so it depends on when you are actually creating it, and yeah, what is the language used and a lot of things. But then basically you have to add these dependencies for your Firebase to be set up properly. Yes, and next configuration is the project level. So you have to be very careful to choose Java or Kotlin, depending on what language you choose. By default, it's Kotlin and Flutter. So for me, it's Kotlin. I'm not sure. Earlier, it was, I think, Kotlin itself. Not sure, but definitely, it's better to check what is the language which you are using in the Android application, and based on that, you have to configure the project levels build.gradle. So as you can see, I've added the Google services here and also the analytics for the Kotlin, right? Right. So yeah, this is something which is important, which is a new latest one wherein this will be automatically updated and the Firebase and all those things. So do add this line as well. So it's always better to add whatever is provided here. Right. So I think that's done. Then you just have to, you're set with your Android app side and your app, whatever is done. Now let's go to the project setup, right? So in the project setup, you have to add the packages to the pub spec YAML. So you have to add a Firebase core. So earlier tutorials, if you see, you will only be seeing the Firebase messaging. So, but then with the latest Firebase, you should add the Firebase core because they have actually moved all the things of basic Firebase initialization into Firebase core. So both the packages are required for FCM. Once you add them, then you just run the Flutter pub get, and then basically you just have to follow the steps from this documentation. So mostly the documentation is good. You just have to follow the steps. I mean, there are two separate documentation, right? One is for setting up the Firebase, and then you have this documentation where you see how this has to be used, how to use this Firebase message. But always remember to use this Firebase core, and which you will have to initialize, right? So let's go through the demo and also the code walkthrough. Yep, let's. Yep. So this is the code. This is sample code. I have actually given the link to that also. This is a sample code from the Firebase messaging plugin. So you can directly use that. Let me go to the code. Yep. So basically what it is that here you have a main method, right? And if you see here that what we are doing is we are calling Firebase initialize app. So this is the first step which is required for the Firebase core to be initialized. So whenever you want to create something in going forward, not just FCM, any Firebase, you have to initialize this. This is a new way of using Firebase. And once you do this, then for example this one, if you see on background message, so what this does is if you want the app to actually listen in the background, like when the message is coming in the background means the app is either closed or app is in the background in the recent apps and things like that. It's not in the foreground, right? So that case you have to create an on background message. So if you see, this on background message is nothing but an async which actually initializes that. So what happens is whenever an on background is called, it just goes here, it initializes the app. So initially not this app, the Firebase. So it initializes Firebase. So that is what this on background does, right? Then if you see it, it actually checks if it is not web, and it has some stuff which it is doing here. I'll explain that very quickly. So if you see here, it is an Android notification channel, and it sets that as high. So you may be thinking why this is required. This is required if the app is in the foreground and you want the notification also to come. Usually when the app is already running and it's on the foreground, the notifications may not come. For example, in WhatsApp, so when the app is running, you will not see notifications coming from in the notifications tab, right? So that thing. But then maybe your app requires the notifications to come even if the app is running in the foreground. So for that scenario, you have to give importance high. So whenever the importance is high, you create a notification channel with this Android notification, right? And you say that importance is high, right? And this is for iOS. So whenever, if you want in iOS the notification channel to be coming in the foreground, you have to do these things. Along with this, when you're creating the notification channel, you have to set that notification channel here as well. So there is a metadata in Android manifest. So you can get all this code in your in that example app, right? So you can find all this code there and you can get it from there itself. So you just have to give this metadata as well. Just this metadata is enough. In older ones, you can see many different metadatas being added into this one, which are not required. With just this one, this whole code works. Let me, yeah. And then it says, it runs the message example app. Let me go to application. Yep. So this is the application here. And if you see here, initially, I am actually getting the instance of this Firebase messaging. And then I am saying, get initial message. So there are different types of messages. As I told, it can be either, no, not different messages are different, but here what I mean is that the message can states. Okay, so the app can be different states. So app can either be running in front of you and you might be using the app. A message can come then. The app might be in the background. The message can come then, or if the app can be killed. So how do you handle these kind of different messages? And that is how we are going to see here. So for example, get initial messages. Let's say the app is terminated. Okay, and then what you're doing is you get a message. So whenever the app is in background, I've shown you that code that when the app is in background, this one is called and it initializes, right? So let me come back to this one. Yeah. So whenever the app is in the background, it you get the notification. What do you do with the notification? That's the next point. When you click on the notification, it comes to this code, get initial message. So it comes to this code, and as you can see here, it it opens another page. That's what he does here. You can do whatever you want, but this is how you handle clicking on the notification when the app is completely closed. On message listen, what this one does is that this listens to the message when the app is currently open. And here you can see that it actually sends this is the Flutter notification plugin, and then sends a Flutter notification. Okay, it's a local notification. And on open, this one is that when the app is running in the background, so it's not in the foreground, but it's running in the background, and then you are dropping, clicking the notification from the notifications tab, right? And in that scenario, it comes here, and here also it actually opens the message. So there are different methods here which you should go through to learn it in detail. I may not have the time for all of that, but I'll show you a few of them. For example, yes, if you see here, Firebase messaging instant subscribe to topic. So what this does is it actually subscribes to a topic named as FCM_test. So in your server or cloud function, you can send a message to this topic. And what happens is it will get triggered here, and it will come as a normal message itself. You don't have to do anything else in the other code. But this, since it's subscribed to this topic, which all applications are subscribing, they'll only get that message. Okay. Yep, and yeah, in iOS you need APN tokens and things like that. Even in web you need token registry. Yep, so that is it. I'll just show you working of this. Yeah, so as you can see here, okay, so this is the console, and what you have to do is in the console you have to scroll down, and under engage you have cloud messaging. Go to the cloud messaging and you click on new notification. Let's give hello Flutter, right? Okay, and let's give next. And from here you have to choose your app. So this is a sample one where you, if you want, you can use this also to trigger, no problems. This is a console based triggering of composing notifications. This is also one way of a secured way to send notifications, right? So okay, I'll say target, it's a user segment or topic. You can even trigger for topics, as I told. Currently I'm just getting user segment. I'll just give, I can schedule it for now itself. Other things are optional. I'll just click on review, and then I'll just show you that the app is actually not running even in the background, so there are no recent items. Then I will publish this. It might take a few seconds for this message to actually get completed and it to come here. So we may have to wait a few seconds for that to happen, right? In the meanwhile, yep, okay, that was fast. Okay, so as you can see, the message notification has come here, right? So this is the same notification what we had created, and if I click on this, what will happen is, as I showed you earlier, this get initial message will be triggered, and it will actually come into this one. So let me click on it. Okay. And what it does is actually opens the app, and it opens that page of the message. Okay, this is a sample application from the Firebase messaging itself. I just copied it. So that is that. And what if you want the message to come when it is running, right? So let me, and that would be let me duplicate this message. So I'll just send that message again. In this scenario, what will happen is it will actually send a message in this, and this one will be listening the message. And what will happen is that it will actually create a Flutter local notification. And as you can see, the local notification, if you see the the logo is different. It's because I have given a logo from this notification, which I actually do not have in the system. So that's why this kind of a notification is coming. Earlier, if you remember, I got a Flutter symbol, F symbol, which is a notification from the SDK itself, the Firebase messaging SDK. Now there is a third state for this, which is the app is in the background. So let me put the app in the background and trigger the notification again. So you can do duplicate notifications here, and you can test out a lot of things. But in order for this to work, in a real life scenario, it's always better to have a cloud function or a server running in the background which sends messages in a timely manner with the scheduled messages and things like that. So, yep. So this is also working. So yeah, that is how this works. So this app is actually in the background, and even if you see here, the symbol has changed because this is actually come from the third method, which is here on message opened, right? And it is not where it is in the background. So let me click on it, and it will actually go into open the app and even open that page, right? So it's now I think I've made it a little bit easier for setting up. It's not that as difficult. You just have to follow these steps, right? Setting up, let's just go through that. So you just have to set up the one second, I'll just quickly go through, right? Yep. So you just have to set up this project, and as you can, that is very easy. And then you just have to add your Firebase to the Android app. Similarly, for iOS app and web app, you just have to follow those steps, right? And SHA key, I told you how to get an SHA key in the easier way. Then you just have to add. Do not forget to add the Firebase core as a extra package, not just Firebase messaging. So whenever you're using any Firebase, not just FCM, going forward, if you are using the latest Firebase packages, you will have to use the Firebase core, and you have to do the initialize app method, which is called at the first line. If you see in the main here, so it should be called as soon as possible because it has to initialize, and some stuff has to go in the background to initializing for registering and things like that. Right. So, yep, that's it. That's it from my end. Thank you.
Hi again, Ganesh.
Yep. Hi.
Thank you so much. I hope you've made it way easier for everybody else to understand what FCM is all about and how they can implement it in their own apps.
Yeah.
While you were on with your talk, we had a few questions from our viewers on YouTube. So, Jayant wants to know if FCM is supported for other platforms like Windows or Mac.
As of now, I didn't see any updates on that. As of now, it's only for web and iOS and Android. We can tweak around a little bit to get it running in desktop, but as of now, it does not provide you a direct package for that. Right? I mean, it's just a REST API calls and it sends, and so there are tweaks you can do, but as of now, it does not.
Mm-hmm. Okay.
Hopefully, in future, maybe.
Yeah, well, that's all we can hope. So, Jayant, I hope that answers your question. Eamon Patel also wants to know if Amazon SNS is similar to FCM with respect to feature set.
Yes and no. I mean, Amazon SNS has. I mean, both of them have its own, pros and cons. FCM, it's easier to start with, right? FCM for a production quality one, I would prefer SNS. For if you're a starter, if you're a developer who wants to experiment with things, FCM is very easy because you do not have to pay anything. You can directly start with a very limited set of knowledge. SNS, you have to configure a lot of other things. Yeah, you have to. Yeah, so that is the main difference, right? FCM is, as of now, it's totally free with limitations, of course. But yeah, so that's the main reason. It's like a it has its own pros. That one has its own pros. It depends on what you want to use, right? There are lots of things which you'll have to figure out on our own, like what is your use case. So if you can tell the use case, then maybe we can go into depth, like which one would be better.
Right.
For example,
Well,
if you have using a cloud function, then FCM is directly easier. you can directly use a cloud function, and you do not have to do much of functionalities with that. You do not have to set up anything, right? It's a Google Cloud, and this is directly linked with Firebase and Google, right? It's a Google product, so we can directly link with that. Depends on a lot of things.
Yeah, well, I hope that answers your question, Eamon. Also, Prajwal wants to know how you can handle notification sounds through Firebase functions.
Yes, so notification sounds are not with the Firebase functions. That would be with Flutter itself. So that would be as a Flutter notifications itself. So I am not sure. I have not yet tried it out. I usually work with the silent systems. But yeah, definitely there are. I think you can use there is another package known as Awesome Notifications, which gives a lot of flexibility with almost all the notifications. You can use that as well. There are lots of plugins. So Awesome Notification is one of the great plugins which you can use without much of the hassle of setting up all these kind of things in the background. So you can try it out. But then I was getting to know that Awesome Notifications is kind of deprecating the support for Firebase.
Right.
The background. So yeah.
Right. Well, I think it's definitely something that we can look into and probably figure more about. And finally, Gaurav Verma has a question where he asks about somewhat of a reverse situation where how you can send FCM notifications to a client when an appointment is booked by the user using FCM.
Appointment is booked by okay. So yeah, so there definitely you need two different apps, right? So so definitely there will be a backend server, right, which would be handling all of these kind of queries. Like for example, client is booking something, and so there are actually, it is like a one server and two different clients.
Right.
One would be booking something, and the other client would be the one which is the backend user, right? So there will be two users and one client, and you can either use topics for that. For example, let's say that you are sending it based on topic. For example, it is topic means, for example, let's say the client is booking something, right? And that there is a cloud function in your Google Cloud, and you have written a cloud function which keeps on checking for that table or that value. And if say that, okay, this user has booked, and then using that cloud function, you can send up FC. Yeah.
Right. So basically we need an intermediary to manage all of this.
Exactly. So easiest way would be if you're just starting up, the easiest way would be to go ahead with the cloud functions. You do not have to think about servers and things like that. Cloud functions gives you a serverless coding. So you just have to write your code in Node.js and JavaScript, and it will run.
Right. Wonderful. Well, I think that's all the time we have for the questions at the moment. So we're going to stop at that. Again, thank you so much for discussing all of this with us, Ganesh, and telling us all about FCM. Of course, I'd love to see you towards the end of the event. So stick around.
Yeah.
Perfect. See you.
Thank you. See you. Bye.
All right, ladies and gents, that was Ganesh, and he was talking about how you can implement FCM in the best way possible for your applications. And we hope that you're going to go back and try it all out on your projects. We have also shared the links that Ganesh has shared in his presentation in the chat, so you can access all of those from there. And well, as far as this event is concerned, we have two more talks coming up for you, which are going to be top notch. I can assure you that. So moving on, I'd like to invite here with me Manas Pratap. He is also a software engineer with us at GeekyAnts, and he is going to be talking about something very recent of his, which is amazing. And I don't know if you must have seen it on Twitter or come across it at all, but let's have Manas tell you more about it.
Hey Digvijay.
Hi Manas, very good afternoon. How are you doing today?
I am fine. How about you?
I'm good. Wonderful to see you again. This is basically Manas's second time here with us on Flutter Meetups. And it's wonderful to have you here again with another one of your crazy projects that you keep spending your time on.
Yeah.
And I'm really excited to see it firsthand myself. But as far as a quick introduction to Manas, he is of course a Flutter developer and enthusiast of sorts, if I say so myself, and he is a lot into blockchain. So I don't know what recent findings you've come across in blockchain, but I'm excited to know. But today it's all about 3D animations, and well, Manas, I think I'll let you take it away and let everybody know what you're doing.
Yep, thanks, Digvijay. That was a great introduction. Let me share my screen. Yeah. So, namaste, and hey, welcome to Principles of 3D Design in Flutter. I am Manas Pratap Thakur, a software engineer here at GeekyAnts, and this is my Twitter handle at the Manas Pratap. And this guy right here is my Dashatar. I did introduce him to you all at the last meetup, but now he won't leave me alone. He just follows me around. If this continues for long, then I'm just going to name him. I'm going to domesticate him, I'm sure. So let's get started. Then why would you want to build a 3D application, right? Because 3D is awesome. Let me show you what we will be doing today. This is an application, goes like this, like this. Looks cool, right? Who wouldn't want to buy something like this? If there was a metric you use to measure the sales pitch, I think this should be at the higher end, definitely. And this talk is not about me introducing something cool that I did. No, it is about seeing designs like this, right? And then having the questions answered, like how do you move forward when you see something like this? From where do you begin? How do you dissect this? That's what this talk is about. How do you move from 3D design to an application? And we'll see using that app as an example, right? Because this is very easy to do. It just looks fancy, but it is super easy to do. And the second thing is Flutter UC is unique when compared to other cross-platform tools in that it makes no attempt to mimic the underlying native SDK. Instead, Flutter uses its own high-performance rendering engine, Skia, to draw the widgets. So, Flutter requests a window from the underlying OS and entirely manages its own content in Skia using Diet. And this is the same approach taken by many of the gaming engines. So, you have control over everything in Flutter. And that's why you should try doing 3D in Flutter. Now, how do you do this? This design at first looks very complex, right? But if you look closely, any 3D design can be divided into two main parts, right? So first is things that you can represent using widgets. So widgets in 3D. And the second is the fancy objects, like let us call them just objects in 3D, right? So any design, you could divide it into these two categories. So let's first start with convert three dimensionalizing a widgets, right? So now Flutter does not expose any 3D API, but it does provide us with a third axis, Z axis, in addition to the X and Y, and we will make use of that axis, right? So the three main widgets that we'll be using is stack, transform, and gesture detector. And you need only these three, nothing else. So stack is a very simple but very important widget for this 3D animation. It contains a list of widgets and positions them on top of the others. So stack allows developers to overlap multiple widgets into a single screen and render them from top to bottom. Now, this is very powerful. So you could literally take anything and place it anywhere in the screen. So let's see how I use this in my application. Right. So this is the stack. Here it is. And at first, so in stack we are overlapping things, right? At first we have the page background. So that is this part right here, this yeah, where my pointer is, right? That is the first layer. And then the second thing is the bike background. So this is a bike background where Royal Enfield is written. Then the third thing is bike itself, right? This bike is the third thing. Then we have the fourth bike foreground, we have bike specs and bike footer widget. So this is the bike foreground, Royal Enfield. It is actually above that, the background. And then this is the specs. And we have a nice cool thing here, that is a footer, right? So this is how we use tags, and we place different components on top of each other, right? Then we have transform, which is a widget that surprisingly transforms its child widget before painting. So after you have placed all the components on the screen using the stack, you'll need to build a scene, right? Like rotating things around, scaling them, translating them, and maybe also playing with their texture. So stack widget provides us with two types of constructors, single operation and default. Now, single operation constructor, as the name suggests, allows us to do only one operation at a time. Then why do we ask it, you ask? Why do we need it? Why do we use it, you ask? Because it is super simple to use, the single operation constructor. So consider this square, and if you wanted to rotate this, you just give it an angle, you give it an origin, and boom, you're done. So it will rotate around that axis. So here we have taken the right vertex, bottom right vertex, as the axis, and it rotates 45 degrees around that, right? So that's rotation. Now, if you want to scale things, you just give it a scaling factor. You again set the origin. So if the origin, here the origin is used to decide the direction in which the square will scale. So if the origin is on the bottom vertex, the whole thing will scale in the upward direction. If it is in the right vertex, it will scale everything in the left direction. So scale will scale, if it is here somewhere in the middle, it will scale everything in equally in all the directions, right? That's why we set an origin. So we have the rotate scale, and then we have the translate. So translate is used to move things around, right? You just give it an offset and that is done. There's no origin parameter here because it does not make much sense, because it is not affected by any origin. You just give it a offset, that is the difference in positions, and we are not specifying any absolute position. So it's only about the offset, right? So we have these three single constructors. Then we have something known as default constructor. And unlike the single operation constructor, this allows us to do multiple operations at once. This is made possible by using a four-dimensional matrix, that is, matrix with 4 rows and 4 columns. So to rotate an object using the default constructor, we take an identity matrix and set the values like this. And don't be scared yet. You don't have to remember this. You can always look this up. So if you want to rotate it around x-axis, you just set the degrees here, like 90 degrees. And same for y and same for z, right? And to scale, we do this. You have this matrix, and if you set the x value, you can scale in the x-axis. Similarly, y for y-axis, z for z-axis. And we have a scaling factor. So this is used to scale in all the three axes, right? So if you want the square to be 4 times bigger, so you give 1/4, that's 0.25, and it will scale it 4 times in all the directions. And then, so you see, using matrix, we have so much of control, right? Compared to the single operation constructor, we can define any axis and all those things. And then to translate using matrix, you set the x, y, and z value to move it along the x, y, and z axis, right? Now we have the secret sauce of our application, this one. So it is about depth. So if you use these three values in the matrix, right, you could set the depth. So what I mean by depth is that the thing closer to you appears bigger and the thing that is further to you appears smaller, right? So here you see, as the Royal Enfield goes away, the D becomes a little small. And that's how we do this. We use the depth matrix. So if you control these values, you can control the depth. So depth in X, Y, and Z. Here I am controlling the depth in Z axis. That is here. So you will see many lines in, I think, some places. If you are intrigued, you will see something like set 3, 2, 0.01. So that is the third row, second column, value 0.01. So the higher the value is, the closer the end will be to you. So if you give something like 0.0001, this would be more further away, right? And yeah, so you add depth. Now let's see how we make use of this translation in our project. So let's see, translate, where are you? Yeah, here I have the single operation constructor. I have used translate. You could use something like scale and rotate also. So this is for, I'll tell you what this is being used for. You see this here, the background is being rotated, right? But as it is rotating, it is also moving in this direction. So a single translation will help me do that. I'm setting the X value to here, it goes there. Then you could use the matrix to rotate, and also remember, like, you also get this property, rotate x and y and z, because I think probably the Flutter guys realized that no one is going to remember the cos matrix, cos and sin. So you could also rotate like this using the this operator, rotate y, x and z, right? So this was to move it in the x, and that rotate y is rotating it in the y direction, right? And this is the depth. So at the third row, second column, I set this value. This is what it is. And here's an extra tip for you. So you can also play around with the colors, like adding the shadow or an opacity to enhance the perspective, right? So here you see Royal Enfield, I have added an opacity. So as it moves away, the opacity decreases. It really gives it that feel. And there's a shadow on this page, right? So if you observe this, as it is going there, there's a little black shadow. So you can use opacity and shadow also to control this, add perspective, right? So we use tag to place everything. We use transform to move things around and create a scene. Then we have gesture detector. It is again a very useful thing. Yeah, it is a final piece of a puzzle. Now, you can encapsulate any widget with a gesture detector, and it will listen to gestures from that widget's layer. It provides us with these useful callbacks, that is on horizontal drag start, on horizontal drag update, and on horizontal drag end. So this on horizontal drag start comes is activated when someone touches the screen, right? And while the pointer is moving, we have this function. And when the pointer ends, we have this function with a velocity. You also have this in vertical. So you have on vertical drag start, vertical drag update, and vertical drag end. And you also have on something like on pan start. So on pan start will give you both the value, I mean directions, vertical also and horizontal also. But I needed only horizontal. So that's what I have done. And let's see how I have used this, right? Here is my gesture detector. So this is my complete screen. I have encapsulated my complete screen with a gesture detector. Here is the start function, update and end. So what I do at start is I mark the starting position, right? And while updating this, I update the position of a variable. So in this case, I've taken the variable as animation controller dot value, but you don't need to use animation controller for this 3D design at all. You could use something like global keys, or at first what that I had done, I had used only local variables, okay? But I used animation controller now because you could just flick it and it will complete the animation. Otherwise, earlier what it used to do is if you leave it here, it would stay here. That did not make sense, right? That's why I have used animation controller, but it's not important. So yeah, coming back to gesture detector. So what I have done is the animation controller value goes from 0 to 1, and the distance, right? What I do whenever there is a drag, I I take the distance horizontal displacement and divide it by the complete screen width. So even that distance goes from 0 to 1. And that's how I map the distance with the value, right? So I calculated the distance, and then we have this, and there's an important line here. So what this will do is it will not return anything. And this is the case when you are here, right? You are swiping to the right, And once you have reached here, and if you swipe more right, there's no use, right? So that's how. So if you're swiping more right after it is activated, the specs window, then we don't do anything. Otherwise, we update the value. And same thing here. So on end, what do we do is two main things, right? We have a drag function. So if a user travels more than half of the distance, and if they just leave it, the animation completes. So this is the drag part. And in swipe, what happens? If you give it a fast flick, right, like this, it will complete. So I take the velocity here and this, okay, and yep. So a very useful widget, I must say, gesture detector. So we place the things using stack, formed a scene, and then we map the movement using the gesture detector, right? And coming to the objects, now Flutter says that they don't expose any 3D API, right? 3D optimized API. So how do we do this? You could obviously use package, right? But I did not use package because first there are a very few to none package, and if you do find one that suits your need, by using packages your speed of development would be limited to the speed of development of the package, right? So there is only as much you could do as the package allows you to. Also control. So if a package does something in one way and you want it to be in another way, you cannot help it, right? So that's why I did not use package. But there is advantage of using package. Like you don't have to do everything. You do all the complex stuff. I mean, you get all the complex stuff and the boilerplate code out of the box, right? So I did not use package, but I used images, right? So images of 3D models. So I have many images of one model. This is good because you have more control over it, right? You have control literally over each frame of the modeling. So now how do you get this model? How do you get this image? So you get this image either from your designer, otherwise you can take a 3D design, right? So I downloaded this open source bike from Avatar. I'll give his profile link in the description later. So I downloaded this bike and I taught myself the basics of Blender. So this is Blender 3D modeling. You could use Adobe also. So here I taught myself things like camera, anchor objects, following the path, making an animation out of it, and rendering the animation using keys, right? So you see here, the bike, what if you break down the animation, the bike goes from side to the top, right? So what I do here is I have a camera, I have a camera, and that camera goes from here, side, to the top. And this thing is your phone screen. Obviously, it is horizontal now. I flip it around when I render it. So this is how I taught myself Blender, the basics of Blender, and I rendered this animation, right, as sequence of images. And then I use the sequence of images here, right? So you can, the main thing here is we have something known as current image. This allows you to set frame for each gesture value, for each position that you are at, right? So if you go to build bike, yeah, here's build bike. So I rendered the animation in 120 fps, right? I mean, I have 120 frames images for that. So I did like this. Here for each animation value, you render a frame, right? At first I had rendered only 60 frames, so I just changed here 60 and here 60. This will work for 60, and this is quite handy. Like if you feel that this animation is slowing down, only 24 would also be enough, right? So when you render things, right, when you render a sequence of images, you get it like at 001, 002, and all those things, right? So here you have something like you increments. So I rendered 120 images from 0 to 120, and you could, and I incremented by one. So first image, second, third, fourth, until 120, and you could increment it like 4, 5. So 1, 4, 8, and like those things, right? You could do like this. So here I'm just rendering a image with a transparent background. So that's all that is there. And thank you. To close, I would like to say that now this looks 3D enough, right? This looks it is very convincing. But I said that Flutter does not expose any optimized 3D API. Now you see here,
Hi again, guys. I think Manas has had some internet glitch. Maybe he's having some internet issues, so we'll just wait for him for a second to come back. Meanwhile, I'd urge all of our viewers to do ask your questions in the chat to Madhav and Manas and all of our other speakers as well. Yes, so we just saw Manas disconnect because of some internet issues, and we're hoping that he will be back very, very soon. While we wait, yes, I just wanted to take this time and talk about, well, I don't think I'll have the time because Manas is back. Let's have him back here. Hi again, Manas. Can you hear us?
yeah.
Perfect. So I'll let you continue with your presentation.
Okay. Yeah, so I was just about done. And yeah, so the closing thing was that you could, the whole code is open source, so you could either follow at Flutter BLR or the Manas Pratap to get the source code. That's it.
While we wait, yes, I just wanted to take this time and talk about.
Yep. Digvijay.
Well, that was an unfortunate moment to get disconnected on. You were almost done with your presentation.
Oh, I'm so sorry. I did not know it was just kind. While I mean, the plus point of that is that 3D rendering takes a lot of system processing, I guess.
Yeah, well, that was actually one of the questions that I had and all of our viewers probably had and was asked in the chat as well. So Darshan wanted to know what are the performance implications of using such a 3D render in your apps?
Okay, so I have a secret formula, right? I call it the 111 principle. So that is, you have an app and you have the main page, right? And then each of those pages has 10 category pages, and each category page has another 10 pages. So it is one at the front, then 10 main category, and each of those has another 10. So that's 111 pages, right? So I define the maturity of a technology being a very naive technology like blockchain. It is very naive, right? You could apply it only at the top one page, right? And then you have this 3D that can be applied at the top one and the next 10 main pages also, so 11 pages. And then if you have something like voice, right, that is optimized now, that is very mature now, so you could apply it at all 111 things, right? So it is quite optimized. Also, this animation is of only this part, right? Only quarter of the bike is 120 images, and I did try it with 30 also, and it works totally fine. So I did not feel so. If you like design only your home page with this, or only few of the main pages with this, it should not be any problem. But if you want to apply it at all the pages on your app, then we might need to think about the performance. Yeah.
Right. Well, I hope that answers your question, Darshan. We have another question from Prajwal, which could be a follow-up to this question. And Prajwal asks, what if the images are dynamic?
Yeah, that's not an issue. So you see how I have used image sequence.dart, right? Here I have used image.asset and I just gave the numbers. Instead of this, you take it from, you take it from image.network and you tell the server to send sequence of images like 1 to 24. And I think for most of the 3D animation, 1 to 20, only 24 images should be enough. So you just increment it here. So nothing is hard coded here. You just instead of asset, you use the network and get it from the server. Yeah.
Right. Great. So that I hope that answers your question as well, Prajwal. And finally, Sanjul asks that you mentioned some plugins for 3D objects in Flutter. Could you suggest some to him?
Yeah, I did discover Flutter. I did discover Unity Flutter, right? It is like what I did, it gives me more control. But you see, I only put a bike there, right? But if you want to put a road, trees, and shops as well, then this would be very difficult using only native Flutter. So you might need to go to Unity Flutter, that is a package, and there is something known as Cube. So even Cube was a good package that I had tried out. So yeah, Unity and Cube, I think you could try that out.
All right, well, Sanjul, I think probably that's something that you can go for and try it out on your own and see if that really works and fulfills your needs. While we were talking about this, I think there's another question that we have time to answer, and Prashant wants to ask what the secret behind the 4 row and 4 column matrix is. And I think a simple answer to that would be mathematics. But
Yeah,
yeah.
so the what I can recall from my high school is for 3D, if you use a 4-dimensional matrix, then you can perform rotation, translation, and scaling all at the same time. So you could use even a 3-dimensional matrix, but then you have to do only one operation at a time, and you already have the constructor for that. That is transform, dot rotate, and all those. Yeah, that would be
Right.
it.
So yeah, that's basically him oversimplifying it for you. So I think it just requires you to brush up on 4x4 matrices, and that will probably tell you everything about that you need to know in these 3D animations. Basically, that's like the crux of it all. Am I right?
Yeah, that's a
Yeah.
good gist. Yeah.
Yeah, pretty much. Anyway, that's all the questions I have for you at the moment, Manas. Thank you so much for this wonderful display of this animation that you've done and made your app so much better and so much better looking, basically. And I'm sure everybody is extremely excited to try this out on their own. And I will see you towards the end of the event again.
Thanks. Thank you.
Wonderful, fantastic. So I'll see you. Thank you very
Yeah.
much.
Bye.
All right. Well, we have come towards the end of, almost the end of this event. We have just one more talk left. And it is my pleasure to introduce you to Chris Swan from the At Company. I'm assuming all the way from Haywards Heath in England. But he can correct me on that if I'm wrong. And he'll be talking about running Dart on ARM servers. So let's welcome Chris.
Hey,
Hi, Chris. How are you doing today?
I'm good.
Super
So,
early
yeah,
for you,
you're
I
dead
presume.
right about Haywards Heath. That's where I am.
Oh, yeah. So I did get it right. Amazing, amazing, fantastic. So, as a quick introduction, Chris Swan is one of the big brains behind the At Company, and he's one of the people who is now responsible for making the internet a much more safer place. Shout out to the At Company; those people are brilliant, and we love them. Also, I mean, I would love for Chris to, if you could tell us a little bit more about what the At Company is and what you guys are all about.
Yeah, sure thing. I'll get to that in the presentation. So
All right. Got it. Got it. Also, I did come across the fact that you are a co-host of a podcast of your own called Tech Debt Burndown.
That's right.
Is that what it's called? Yeah, and you co-host with Nick Selby. So could you tell us a little bit more about that?
Sure thing. So it's a podcast about technical debt and how people deal with technical debt. We've had sort of 10, 11 guests on it now, talking about various different aspects of tech debt with security, tech debt with observability, tech debt with things like software bill of materials. And so actually we'll be dropping, I think, the software bill of materials episode tomorrow. I guess I'm not supposed to pick favorites, but the recent one we did with Charity Majors on observability is absolutely fantastic. So highly recommend that if people want to kind of dip into an episode, try it out.
Well, shout out to the Tech Debt Burndown podcast as well. Go check it out. It's everywhere. You can find it on Twitter. Just follow the account, search it on Twitter, and you'll find it. It's pretty easy to get to. Anyway, so Chris, I'll let you have the stage and tell everybody what's going on today and what you're here to talk about. And
Thank you very much.
Yeah, take it away.
All right, so share my screen, and I'm going to be talking about Dart on ARM. And so let me just complete the introduction. So as was already said, I'm an engineer at the At Company, and we're building a platform that puts people in control of their data. I'm co-host of the Tech Debt Burndown podcast, and also a cloud editor at InfoCube. So I write there about cloud DevOps, certain security things, and various stuff around performance. Links to Twitter, LinkedIn, etc. You'll find all of those at chris.swans.net. So all of my various social media profiles are there. So here's what I wanted to kind of take folk through today. I'm going to start out with why ARM is important. And that really comes to this notion of full stack Dart to complement Flutter apps. So Google's been pushing pretty hard on this idea that if you're developing a mobile, web, or desktop application using Flutter, then you're learning Dart to do that. And why not then use Dart to write the APIs for the backend? And then the other piece to the puzzle is ARM growth in the cloud and the Internet of Things. And I'll show you some charts of just how huge that's becoming. So, I think we're all very used to using systems based on the x86 architecture, but the growth of ARM is really big right now. And I think that means that we've got to factor in how we're going to use ARM in the future. So Dart has two ways of running the code. We can use just-in-time compilation in the virtual machine, and we can do ahead-of-time compilation. So I want to briefly look at the various trade-offs between those two things, because it kind of factors into how we build things to run on different platforms. I'm going to touch upon the dependencies for building and running ahead-of-time binaries, because that's a big piece of why we need to treat different architectures differently. And kind of everything by default is set up for x86. So how do we get from that x86 default to being able to build things for ARM? And then, kind of wrapping up, I'll show how we can make cross-platform building very easy. So we can have automated systems that are going to build things for x86 and different flavors of ARM all at once. So, no need to kind of be kind of manually stepping through, let's first build it for x86 and then build it for ARM v8 and then build it for ARM v7. It can all be done at once. And hopefully some time at the end for questions. So starting off then with full stack Dart. At the recent Google I/O event, a lot of the talks that were focused on Dart were actually focused on this idea of full stack Dart. So there was an Ask Me Anything on Cloud Dart and full stack Flutter, and then also a set of talks on full stack with Kotlin or Dart on Google Cloud. And in many cases, that was encouraging people to use Dart and Google Cloud Functions or Google Cloud Run in order to provide the back end to Flutter applications. Google have also done a podcast on this, a recent episode of the GCP podcast, just called Full Stack Dart. And that was with Tony Pujals. And Tony is one of the core Dart SDK developers at Google. So I see his name popping up pretty frequently. He's recently spearheaded the work for the Dart official image in Docker, which I'll be touching upon in just a moment. So as I said, the other piece to this puzzle is ARM growth. And ARM growth is huge in the cloud. And ARM is, I think, already the predominant architecture that's in use by devices for Internet of Things. So a little while ago, Amazon launched a new range of instances using their own silicon based upon the ARM architecture. And that recent release they call Graviton 2. There was an earlier Graviton, which was just Graviton. It wasn't Graviton 1. But I kind of, in retrospect, we might call it Graviton 1 now. And looking back over 2020, we can see that Graviton accounted for 49%, so almost half of the instance additions to the AWS environment. And so very quickly, we can see that it's becoming kind of the dominant strain, if we could use that terminology, of instance within Amazon Web Services. And that really comes about for a few reasons. One is price, that because Amazon's using its own silicon here, it can offer that at better price points, but also performance. And so the performance from these new ARM-based instances is really good. And I think seeing similar thing in the cloud there to what people getting the new M1-based Macs are seeing with the performance of those. And so then the overall price performance equation of ARM in the cloud becomes pretty compelling. And then there's the Internet of Things. So this is a picture of a Raspberry Pi Model 4, so the latest version of the Raspberry Pi. This has a 64-bit ARM v8 system on chip on it. And these kinds of devices, whether they're being used by hobbyists to try things out, or whether they're kind of going into compute modules or fully integrated systems, are what we see in just about everything running on the edge for the Internet of Things. And so, server class hardware, but in a really small package with a really low power consumption, where we can run things very close to the sources of data that we might be capturing in, say, an industrial environment. So in the intro, I was asked to talk about a little of what the @sign company does, and this I really want to focus on. Why are we interested in ARM? So at the @company, we're building the @platform, which is a platform for privacy-preserving applications. And there's really two very simple components to this. So a root server is almost like a DNS server, and that gives people a place where they can look up one of our identities, which we call an @sign, and find the infrastructure associated with that. And that infrastructure we call a secondary server. And these secondaries are essentially a private server that people have in the cloud where they can store their data and have fine-grained control over how applications have access to that data and how that data is shared with other applications. And we call these things secondary servers. So one of the things we do at the @company is we run secondary servers. And so we've got a whole bunch of those running on top of Google Cloud. But we also want to give people the flexibility to run those secondary servers wherever they want. So something we recently launched is the Distributed Edge Secondary Server, or DES. And people can run that on a cloud virtual machine or a Raspberry Pi or any other kind of device of their choice. And so part of why we want to be able to support ARM is give people the choice, not just between running on our service and running where they want, but when they choose run where they want, then they have the choice between x86 or ARM, whether that's in the cloud or a physical device that they're managing for themselves. And of course, we want to have those choices as well. So at the moment, Google Cloud is purely x86. But we might want to be able to run some of our secondaries on other clouds like Amazon, where ARM is starting to really gain traction. And we also want to be ready for when Google starts having ARM in their cloud as well. So I said I'd talk a little bit about just-in-time versus ahead of time and the various trade-offs that we have between those different approaches when we're using Dart. And I'm going to illustrate this with a really trivial application that I've got here that I call Dart Show Platform. And it's just a slightly more useful kind of a hello world. And so the source code for the application is in this top box, and it's just literally a handful of lines of code. And the key line here is this print platform.version. And the output that we get from that is shown at the bottom. And this is very similar to what you would see if you ran Dart ---- version. And so when you call Dart ---- version, it's essentially printing this platform version information. So it's giving us some pretty useful stuff here. So it's first of all telling us the version of the .sdk and which channel we're using. It's telling us when that was built, and it's also giving us information about which architecture that command has just been run on. So when I copied these particular output snippets, I was running at the time on a Raspberry Pi 4 with Ubuntu, which is a 64-bit operating system. And so it's telling me that it's running on Linux ARM64 there. So with just-in-time compilation, I can just use Dart run and take that source code and run it in a virtual machine. And so on my command line here, I've started off with time, so it's telling me how long things take. And then I've just done Dart run show platform.dart. So that source code that was on the last slide. And it's given me that output. And it's telling me that it's taken about 5 seconds in order to run that, which is a pretty big chunk of time. We wouldn't want users to be waiting 5 seconds all of the time in order to get something as trivial as that version information. And that kind of shows the overhead of starting up the virtual machine in order to get our output. So in order to get past that overhead, what we do here is use ahead of time compilation. And so if I, instead of saying Dart run, say Dart compile Emcee and feed my source code in there, then it's going to create an executable for me. And by default, that'll be called showplatform.exe. And I can run that again with time. And we can see things that are much better here. So it's taking 23 milliseconds instead of almost 5 seconds. So orders of magnitude faster. And this is really the approach that we're going to use for something like Cloud Functions, because we want a Cloud Function to be responsive when we're calling it from a mobile application, in order to get the answers from that function back to the mobile app and the user making use of that mobile app as quickly as possible. So ahead of time compilation gives us very quick startup. But the trade-off there is we're not able to observe the application running in its virtual machine over a long period of time. And so we miss out on some of the optimizations that we can get from just-in-time compilation over the longer term. Another part of the trade-off is compilation is slow. And so if I time how long it takes to actually do that compilation, I can see it's taking about 20 seconds here. And so that means I don't want to be compiling stuff all of the time. I want to be doing my compilation as I'm preparing a function that I'm going to run in the cloud. And then the user is never having to wait for that. So moving on then to the dependencies for building and running an ahead of time binary. Well, if I was to package up my trivial application here using Docker, then I can use a two-stage Docker build approach. So the first stage, I can be using the new official Dart image, and I say use that as build, which I use later on. And all I'm doing here in the next few lines is saying a working directory of app, copying in my source code, and then running Dart compile Emcee on that source code with an output file of Dart show platform. Now, the second part of that build, I'm then moving on to using the from scratch pattern. And scratch is an empty image in Docker, which means that I can have things really small. And with other languages like Go, it's possible to create a statically compiled binary and just copy that binary into a scratch image. And that's all we need. Now, Dart isn't a language that offers statically compiled binaries. Part of the philosophy of the language is to use a dynamic runtime. And so what I need to do first here is copy in that runtime environment. And then with that runtime environment at my disposal, I can then copy in the binary that I created in the first stage and define that binary as my entry point. And so this gives me a little container that I can use to wrap around my application. And that's the kind of thing I could deploy into Cloud Run in order to serve as an SDK or something like that. So if I take a look at what's inside of that runtime, then these are the library dependencies that are kind of the minimal part of what I need for Dart. And so what do we see here? So networking, SSL, libc, libdl, libm, libnss, which is for naming, pthread, resolve, which again is for network, and RT, along with the platform specific libraries, and then lastly the certificates. And the final part of this is just copying all of those into place for the runtime. So all of that works for x86, but how do I get ARM? Well, what we've done at the App Company is create our own build image, which is essentially our fork of the Dart official image. And inside of that, we've created some conditionals that allow us to detect which platform we're running in, and then make use of the architecture specific pieces of those different platforms. So you can see we're starting out here with a case statement that's based upon uname -m. And uname -m is going to tell us which hardware platform the operating system is running on. So there's 3 possible outputs here that we're dealing with. So the first is ARMv7, so that's 32-bit ARM processors. The second is AArch64, so that's 64-bit ARM processors, so V8 and V9. And then lastly, we're kind of catching x86 as the default and having the architecture there. And all of these other blocks are just copying in the platform specific libraries for each of those. And then having captured that architecture label, we can then just use that as part of the environment to then copy in all of the generic pieces that we need in runtime. And so, the rest of this is kind of similar to the set of libraries that we were copying in before. It just puts in the specific architecture libraries, whether that's ARMv7, ARMv8, or x86 as appropriate. So at this point, we can make cross-platform building very easy. And so here's the Docker file now for the same Dart show platform. And the only thing I've changed is instead of having from Dart, I've got from @company build image, because this is using our cross-platform fork of the build image rather than the Google Dart official image in Docker. And I expect in not very long, that official image will also get ARM support, and I'll then be able to drop having to have a fork, and I'll be able to just do from Dart and expect to get that cross-platform support directly from the official image. So if you look in the GitHub issues for Docker, there's already a conversation happening with people like Tony Pujals about that topic. And it's clearly something that people at Google even are interested in and are working on. If I then move on to using GitHub Actions in order to build things from these Docker files, then here's a snippet, which is the build and push section from my GitHub action. And this is making use of my Dart show platform Docker file, which was on the last slide. And in order to get output for multiple platforms, all I need to do in this final section here of platforms is list out the platforms that I want support for. So I've got Linux AMD 64, which is my x86 builds, and Linux ARM64 V8. I'd note here that as I've talked through this, that's now 3 different ways that people have of talking about the different platforms. So, sometimes we're talking about ARM64/V8, sometimes we're talking about ARM64, sometimes we're talking about AArch64. And this is just one of those naming issues in the industry that we have to live with, that people use different names for the same things in different contexts. And so our code needs to be kind of correctly using those in the appropriate contexts. So here's the end result. These are some screen grabs from the @company repos that we have on Docker Hub. And so these are the automated builds for that trivial Dart show platform application that I've been using it as an example here. And what we can see is, the ARM version is really, really small. So that gives us a 3.6 meg binary image. AMD 64, the x86 version, tends to be a little bit bigger, generally about 0.9 of a meg bigger. And that's just larger libraries being carried around. So that's all well and good for a trivial hello world with a bit of platform information application. But what about a real application? So on the right here, I've got a real application, and the sizes are being obscured by my video image. But our secondary server that I was talking about earlier on, and so a core component of our overall architecture, with this approach, we can get a 5 meg image for ARM and a just under 6 meg image for x86. And so that gives us a really small image, which makes it very easy to kind of deploy that out to edge locations, and gives us kind of minimal latency whenever we're having to update that in a production environment. So to recap then, ARM is important for 2 reasons. The first is because full stack Dart gives us a great way to complement Flutter applications by building Dart applications to implement APIs on the server side. And ARM growth is huge in both the cloud and on the Internet of Things. Dart gives us a choice between just-in-time compilation and ahead-of-time compilation, and there are trade-offs there in terms of performance. But for things that we want to start up quickly, then ahead-of-time compilation is the way to go. And that's generally what we're asking for when we're doing things like Cloud Functions. And so then there are various dependencies that we have to have for building and running those ahead-of-time binaries. And in order to provide those different dependencies, we can take what has been done for x86 with things like the official Dart Docker image and create multi-platform approaches of that in order to get ARM support. Once we've got that ARM support into the underlying build images, that then makes cross-platform building very easy for us. Which now brings me on to some time for some Q&A. So I've seen some questions appearing in the background. I will move on to answering those.
Hello again, Chris.
Hi.
Well, you're right about one thing. We do have questions for you coming up in the comments. So one of our fellow speakers, Ganesh, he's actually posted a question in the chat, and he wants to ask you if Dart can run in a 32-bit ARM environment, something like ARM Cortex M4 CPU running at 64 megahertz, which is used in Adreno Nano 33 BLE, which is used for TinyML kind of thing, etc.
Yeah, so if we think about the different classes of ARM processor and Dart support for those, then Dart support presently goes down to ARM v7. And so that would be a sort of Raspberry Pi version 2 kind of setup, but not all the way to some of the things that you've got in really low power, kind of low surface area devices. So yeah, that's where we get into ARM Cortex. And the dividing line here is essentially, can it run Linux or not? Because if it can't run Linux, then you haven't got this kind of underlying capabilities with those libraries I was talking about in order to be able to run a Dart compiled binary. So we can get to ARM v7, which is lower power 32-bit systems, but not all the way down to the small Cortex footprints, because those Cortex footprints are expecting us to run something that's been compiled with a real-time operating system rather than running Linux and then running an application on top of it.
Right. Well, Ganesh, I hope that answers your question. I hope Chris has told you what you really wanted to know. Moving on, we have another question that just came up from Sanjul, and he asks if there are any frameworks, server-side frameworks rather, for Dart that support ARM with this.
Well, so the nice thing about Dart being a virtual machine language, but then offering this ahead of time compilation, is it's agnostic actually in any of the frameworks what the underlying platform is. And so I can take a Dart application and all of the dependencies that we've got in the pubspec YAML, and they don't care about whether I'm going to be targeting that onto x86, ARM v7, ARM v8, because all of those concerns are being taken care of by the SDK, the virtual machine, and the ahead of time compilation frameworks. And so the choice between x86 and ARM is not one that matters as I'm writing my Dart source code. So I can use all of the Dart server-side frameworks and not care about whether it's going to be actually ending up running on Intel or ARM.
All right. Well, I hope that answers your question as well, Sanjul. And with that, we don't have any more questions at the moment, Chris. We'll wait for some time for them to show up if there are any. But yeah, I'd love to keep you here with me and also invite our rest of the speakers for the day, for the end, because we have officially reached the end now. So, well, Ganesh is here, and who else is next? Madhav is here, Manas is here, and we're missing Viral. And Viral is here too. Great. Perfect. We have all of you here. So, ladies and gentlemen, thank you so much for bearing with us towards the end of this event. We have finally reached the conclusion of today's Flutter remote meetup. And I present to you on the screen all of our esteemed speakers today who have taken out the time to come here and tell you new things that's been going on in their lives and talk to you about new experiments that they've been doing and hopefully have given you some kind of inspiration to try out new things. To all of you, once before, when we used to do these physical meetups, we had this little tradition of clicking photographs with everybody, but I don't think we can do that anymore. So we'll have to make do with a small screenshot. So if you guys don't mind that, on the count of 3, we'll say Flutter and then take a quick screen cap and keep this in the records as a memory. So I'll just count it down for you guys. 1, 2, 3, strike a pose. Flutter. All right, I think we have it. Brilliant. So towards the end of this event, first of all, I'd like to thank all of our viewers on the various platforms that we were live on, YouTube, Instagram, Twitter, Facebook. Thank you so much for joining us and taking time out of your Saturday to talk about and listen to these amazing speakers talk about these brilliant things that they've been doing. Second most, I'd like to thank all of you guys. Thank you so much for taking out the time and joining us here and addressing our viewers and speaking to them and sharing what you have. You guys are awesome. You guys stay awesome. Third of all, I'd like to extend a huge shout out to the team that's been working in the back end to make these events possible for us. As always, Rishabh, Maheshwari, Shweta, Bhushan, all of these guys who are working in the backstage right now, making this event as you see it, as wonderful as it can be. And lastly, as a closing note, well, I think since the COVID pandemic has begun, we have been learning a lot of lessons in life. And I think one of the most important ones is to be nice to each other and just to take care of yourself and the others around you and to love unconditionally. And I think that it's important for all of us to take care of your loved ones, take care of your friends, your family, be kind to others, be helpful to others. and most importantly, take care of yourself and your mental health, and put yourself first and foremost in everything that you do. And with that, I'd like to conclude this event. Thank you so much, guys, for taking out the time. I think it's a beautiful Saturday. Go out there, get yourself a milkshake, or make one at home if you like. I think that's the weather calls for a nice, decent milkshake today. So thank you so much, guys. Thank you for taking out the time, and thank you all the viewers for sticking with us, and we will see you next time. Thank you so much.
Bye. Thanks.
Thank you for having us. Bye.
Bye-bye.